So in this video, we're gonna talk about the root test. This and actually the this and actually the ratio test is probably one of the more common tests you'll see. And the idea is that we're gonna take a limit as n approaches positive infinity of the nth root of the series, and that's gonna equal some value p. If p is less than 1, then an converges. If p is greater than 1, an diverges. If it's equal to 1, then no conclusion. Now, there's a couple things that we need to remember. Okay, the limit as n approaches positive infinity of the nth root of n, that is equal to 1. This is also true for the nth root of n squared. This is also equal to 1. This is also true for the nth root of n to the third power. This is also equal to 1. This is also true for n is equal to the square root of n, the nth root of n to the fourth power. That is also equal to 1. So we need to, so this goes on and on. So this could also go to 4. This could be 5. It's also going to equal 1. So we need to keep that in mind. Okay. And so let's look at a couple examples. So what if we're given this on an exam and we're asked to determine whether it converges or diverges, okay? Where n is equal to 1 to positive infinity of n squared over 2 to the n. Okay, and a quick way of determining, sometimes I like to, usually when I see some sort of number raised to the power, I usually like to think of the root test as a first option, and then maybe we could do the ratio test. Okay. But again, this is a root test, and so if I look at this, I'm going to take a limit as n goes to positive infinity of nth root of the whole thing. So this is the nth root of n squared over 2 to the n. Okay. Now, because we're taking the nth root, we could also rewrite this as the limit as n goes to positive infinity of the nth root of n squared divided by the nth root of 2 to the n. Okay. Hopefully we could see by now that this is 1, just like we said. So in fact, the limit as n approaches positive infinity will actually be 1 over 2. Okay, the nth root of 2 to the n is just the n's will cancel out. Okay, and that will just give me 2. So my limit is actually 1. My limit is actually 1/2. My limit is actually 1/2, which is less than 1. So therefore, we can conclude that summation of a n actually converges. Okay. Let's look at another one. What if we wanted to determine whether this converges or not? So 2 to the n over n cubed, where n is equal to 1 to positive infinity. Well, to me, it looks as if I take a limit as n goes to positive infinity of the nth root of 2 to the n over the nth root of n cubed. Well, that looks to me as if this is equal to the limit as n approaches positive infinity of, well, actually, I don't even have to rewrite the limit, okay? But let's rewrite it. So it looks to me as if this is equal to the limit, well, 2 to the n divided by n, well, that's just 2 on the top. So this will be equivalent to 2 on the top. And well, remember we said n raised to the n to the third power, or even to the fourth power, doesn't matter. That's just equal to 1. And so in fact, our limit is actually equal to 2. Okay. Well, we know 2 is actually greater than 1. So we know in fact summation of a n actually, well, not summation, but the series actually diverges. Okay, so again, this is a quick way we utilize the root test. So let's look at one more. What about this? What about an exam you're given this where n is equal to 1 to infinity of 3n plus 2 divided by 2n minus 1. And this is all raised to the nth power. Well, again, quickly as I see this, I'm thinking about the root test. And so if I take a limit as n approaches positive infinity of the nth root of 3n plus 2 divided by 2n minus 1 raised to the nth power. Hopefully you can see that our n's will actually cancel out. And so this will actually left me with a limit as n approaches positive infinity of 3n plus 2 over 2n minus 1. So this is 2n minus 1. Now remember from calculus 1 class, or from your cal 1 class, we said that if we have the highest powers are equal on both the top and the bottom, and then we just simply take the ratio of their coefficients to be our limit. And so in this case, our limit will actually be 3 halves. Okay, this is a 2, so our neural limit will actually be 3 halves. Well, to me, it looks as if 3 halves is actually greater than 1, so therefore we conclude that the series actually diverges. Okay, so that's just a quick synopsis on the ratio test. Again, nothing difficult.